Okay, so before again we start going in and making game art, I want to show you guys some modeling stuff, just so we're on the same page and you guys kind of are armed with the same techniques, or some of the same techniques that I'm going to be using. Take some of these, use them, don't use them. It's kind of up to you. But I do want to make sure that we're all familiar with the stuff because with pretty much everything in life, there's a million and one ways to do things, and the way I do things might be a little different than the way you do things, and vice versa. You might do things different than I do, and maybe they're more efficient. So I just want to show you guys the stuff that I'm going to be talking about pretty heavily. Um, so first off, let's talk a little bit about subdivisional modeling, okay, or sub-D modeling. Okay, sub-D modeling is the idea of taking a. Let me actually customize. I'm going to set this up really quick. Customize user interface. Okay, under my quad menus here, I need to set up some stuff. So I'm just going to come down here. Swift loop. Huge. Love this thing. Save. Yay, max start. Yeah, that's fine. It should be under there now. Swift loop. Okay. Subdivision modeling is basically the idea of taking an object and based off of essentially tension, subdividing that object, and where there's supporting edges, you're going to get really nice crisp edges. Where there isn't, you're going to get nice smooth open edges, or edges are going to contract into a circular form. What does that mean? I'm going to show you. So I'm going to turn on here so we can see what the heck's going on here. Realistic, display selected, shaded with faces, edge faces. Turn off the grid here so we can see it. Okay, so I'm going to come down here. Doop, doop. Now again, the modifier that I'm going to be using is different for other programs. In other programs, this is mesh smooth or just subdivide. In Max, I'm going to be using turbo smooth, which is a modifier. We're going to be doing as much of this stuff as we can in a modifier stack. Okay, so what you can see just happened here is I have one iteration. I'm going to crank this up a little bit. And on the base, turn this off. On the base, you can see this is just the object, okay? There's no supporting edges. And since there's no supporting edges, it's kind of averaging this edge out. You can kind of see the S curve that's starting to follow, okay? If I go to add some edges, swift loop. Actually, those edges aren't going to do anything because there's nothing to the edges. If I start to add edges, though, I can start to harden these lines. Okay? Very cool. Okay, this is useful, especially if you need to define curvature, right? This is, if you want to do a nice inset, okay? That's really some useful stuff to deal with. You also have a number of other options in here with Turbo Smooth. I can say, hey, use the smoothing groups, okay? And what is a smoothing group? We're going to talk about that. Smoothing group is basically the angle alignment of each of the face normals. And this is where stuff is going to get really fun too. Face normals are extremely important for hard surface modeling in games. In fact, truth be told, for most of the hard surface assets that I do, including guns, weapons, unless they are a more stylized approach, like if they're very realistic and it's for a very realistic game, I don't use normal maps unless it's for scratches or dings. Meaning most of the forms in there are modeled out. If there's a bevel, it's in the model. And there's a number of reasons why I do that. Primarily, it tends to look much better than a normal map does. It's also faster for me than it is to actually go in and actually rip a normal map for some hard surface stuff. And later on in the demos, I'll show you some of that stuff as we're going. But I'll essentially do something like this. We don't even actually need to add 3 edges, but I'll show you 3 edges and I'll show you what happens when we remove an edge. Take this. I'm going to auto smooth. Okay. Turn off this. display selected, display. Okay, so nothing really happened there. And that is because this angle, the smooth angle, is so low. So I'm going to set this to like 180 degrees. Okay, see how that's smooth? I want you to look what's happened here, okay? I have a smoothing group now. Both of these are set to 2. Okay, so I can come into here, and I can say, hey, I want this to be a nice smooth transition. Okay, so I have the same smooth transition that was happening, that we got with the subdivision, but it's happening now in the normals, and I have this little edge seam here, so just assign another smoothing group to that, and I'll get rid of this realistic shading because it's kind of borking this. Okay, and from here, we can also, maybe if we needed to, we could remove an edge. Now, obviously we lost some of the volume here, so let me show you how we can furthermore control these edge normals. So I'm going to come under here, and I'm going to go under normal, edit normal, sorry, edit normals. Look at that. Isn't that very self-explanatory? Typically those are too big, so you just want to turn down the edge length here. I can tell this to select by face, I can tell it to select by edge, or I can say, hey, select by vertex. Typically edges are really nice because we can move them around, and you can see how the shading is changing. Okay, so this is actually the direction, and a normal is just a line. It's just an arrow that's coming off of either the vertex or the edge. I can say, hey, since I have these 2 edges selected, I can tell it to unify, and that's going to unify this edge. So it kind of gives me the illusion that it's beveled. Like, it looks like it's beveled, right? But there's not. It's just it's nothing. It's just an edge. It's a kind of a nice way to fake it. One of the benefits for doing this, and we can say unify. Actually, I think we just want to average this. Average selected. Yep. Boop. Nice and smooth. One of the benefits for doing this is, I remember in the previous lecture when I was talking about object mipping, meaning if there's not enough memory, it's going to start to compress the texture. If you're using a normal map to define your hard edges and your angles and your plane changes, especially on hard surface stuff where 90-degree angles and 45-degree angles explicitly tell you everything, your object is going to look pretty bad pretty fast. And it works really well if you have a 2048 normal map. But when optimization comes in games, the first thing that typically gets hit are your textures, and then it's not the character textures that get hit first, it's the environment textures. So on average, depending on the asset, depending on your engine, it is typically, and I'm saying typically, it is typically cheaper to use more vertices than it is to use more textures in a more complicated surface, okay? And again, I'll say it again, typically it's cheaper to use more vertices than it is to use a heavier texture or multiple textures and a heavier shader. Okay, if you have to maintain texel density on an object and you have to do 2 or 3 normal maps, that's a really, really heavy object then, regardless of the poly count. Okay, just on the actual rendering of the object, at the texture fetching of the object, it's very expensive. So again, environmental art is all about trade-offs, and typically I like to make my trade-offs in higher poly counts for objects and more simplistic shaders, and even in some cases smaller maps. Okay, every artist works differently, but this is how I work in my day-to-day job.